and we are good to go. So for part two, just to recap part one, obviously we went over topography last time and a little bit of scaling. I know it was maybe about a week ago, so just kind of a recap I think is fresh. Of course we have the abstract model, the stairs that of course should be completed today, and more or less what we ended up with last time. I know it was kind of a hyper situation where we were kind of just fake it until we make it in order to get a point across. However, for today, I'd like to show you how to put them together and what I'd like you to do for this assignment particularly. And, well, let's laser cut it as well. So I'll probably stop this video at the end, and of course it'll continue with really kind of a laser cutter portion, at least set on the new situation that we have with the laser cutter, and that way everybody's familiar. However, the first things first, this is actually where I use group, right? Because obviously some of these are completely separated, and I kind of want to keep them separated, but for right now I need to move them all at once, right? So again, don't get me wrong, join technically helps me out now, right? If I join it, well, actually join doesn't work to three-dimensional objects. It only works to two-dimensional objects. So what do I need to do to put it together? Boolean union, that's so right. Thank you guys. So if I do Boolean union, that's great, but it doesn't keep separate pieces, right? So I definitely don't want that. In my case, I will group it. That way it's still one piece and I can move it around successfully without accidentally moving one of my pieces or having to select every piece every single time I want to move the entire topography area. But I'll do the same thing, spacebar and spacebar, obviously to enact the group command again. But again, what's really nice is now I can move these three pieces and only have to worry about these three pieces, and I don't have to worry about things getting out of track or out of the area, right? So of course what I want to do first is probably get the stairs into here and then get the whole thing onto there, right? To be fair, it doesn't really matter how you do it. Some people go internally to externally, some people go from external to internal, and that's totally fair, right? But really, realistically, I want to use gumball and play around with it a little bit. Go, well, that's not going to work, right? I got a bunch of poles going through some of my situations and things like that. Oh, well, it kind of actually looks cool in some areas, and I could potentially, of course, get rid of things. I can move things around or grids. That's actually looking pretty sweet, not going to lie. Look at that. Held by an I-beam over here, goes along. And so the whole point of this exercise, guys, is to see that you can model stuff without necessarily accepting it, right? That's actually the definition of intelligence, is being able to play with an idea without necessarily believing it yet. But in our case, we can do a few things, such as rotate it, right? Well, not like that, right? Obviously, I'd want to get the blue one there and hold 90 degrees, and so hold shift so that it, oh, that might actually work better. Well, we're kind of off put by a wall. However, at the same time, if I can start moving things up. But for the most part, I want to make some decisions here, right? Because I don't want to be moving it around all day. But I'm making the big decision first. Ooh, I kind of like that area. That's pretty sweet. But really a lot in the way over there. So one thing I could do is make it a little offset, and that's totally fine for this project. If you guys want to do something like that, where it's kind of like a stair that goes into the project. We've definitely allowed that before. It still doesn't really help us out in this situation. I guess technically I can get rid of a few of them, but you'll see what I mean as we go farther and farther into this process, right? A lot has to either be moved around or very little. So I would test a few things first, just like what I'm doing here. For the sake of tutorial today, I'm just gonna kind of fake it till I make it and pick one. However, I don't want to make an absolutely horrible decision, so I do want to look at it a little bit. That's an easier fix, right? And that's a pretty easy fix too. Yeah, I can lower that one a little bit. That would look okay. And that's going to be okay. It's going to be a gigantic hit, but we can work with that. And to be fair, I kind of like what's going on up there spatially. You guys see that? It's kind of nice, right? I mean, again, this is what I'm trying to get you to get at, is to take a look at what you've done the same way that you would look at a model physically if you built it, right? But let's say that was good for today. Next thing I want to do is get it on the plate, or on the topography. So maybe I want to center justified, maybe I don't. But again, selecting something is way easier when it's grouped like that. I mean, guys, I used to spend like 30 minutes just like selecting everything, and then I'd accidentally deselect it and have to select it all over again. But it is on this little hill, And I may realize that, oh man, I kind of want to put my stairs up a little bit. Sweet. So we can sort of guesstimate exactly where we want to be. And I could raise some things up with my model as well. Not a big deal. I could also end up chopping off some of my stairs at the bottom too. Not a big deal either. But that's actually looking pretty sweet. And, you know, I think it settles it. That is what I'm going to end up with today. However, just in case I wanted to change it later and I just ended up not realizing, maybe I had some potential later, I'm going to make a copy. That way I don't really mess up. Again, if I mess up here, I just try again, right? Or I've already got some of those things set. So I'm going to select everything and ungroup it and start working the magic. First, I'm going to get rid of things that I know I don't need, like my bounding box. No longer need some of those elements, right? So I'm going to clean up a little bit. And this is where the fun begins, right? Essentially what you want to do is eliminate anything that is potentially in the way of laser cutting. So laser cutting doesn't do very well to one-dimensional objects. However, it does cut two-dimensional objects pretty easy. In our case, I would say start at the bottom and start to eliminate wire cut, subtract, move, right? But I'm going to just do a couple of them for the sake of obviously the tutorial today. But essentially in part 2, what I'd like you to do is make it work. So in my case, obviously I need to get some of that out of the way, otherwise I'm going to hit my head as I'm going up. So one thing that I can do is I could subtract it, I could Boolean split it, I could chop it off with a wire cut. Like I said, there's like 15 ways to do something. Another way to do it is I believe I can actually move face. So if I move face, I could take that face, boop, enter, take a point, and basically move it back. If I hold shift, it should stay straight. Again, never put near on because you'll run into a lot of things there. But I can move things back, right? Or at least get things out of the way. I could try that again. And you can move it back to a certain point as well. So if I know a certain point, such as that one right there, and again, I can move it right back, no problem. So while still maintaining the other side, which looks pretty sweet. But again, I essentially want to go up the entire stair section and make sure that, you know, I'm not having to walk over things or walk under things and all those kinds of interesting setups. But I'm going to move face again, get those out of the way. Sweet. Not too shabby. Oh man, what do we do for this piece? Well, it's totally your project. You can do whatever you want, right? If that needs to go on the ground, let's put it on the ground. Sweet. That could be a really cool area potentially. You know, I'm thinking Kernodle's project. Anybody in design one for Kernodle? Nobody? Really? So he has this project that's literally right outside our door where he takes a bunch of abstract pieces and makes you turn it into essentially an observation tower, right? A very small one, but definitely a very similar project to D1, but now entirely on the computer. So definitely interesting there. However, this could potentially help us. I might want to keep something like this, right? Especially since I know the stairs aren't going to just magically hold up themselves. However, another thing that I could potentially do is stay aligned on the grid, but potentially just move it, right? Not a big deal there. And maybe it actually ends up hitting the bottom of the stair. Totally fine. But again, I would recommend that you kind of stay within some sort of grid because we do eventually need to build this. However, knowing that I need to build this, would it take more time or less time if I eliminate some parts? Take less time if I eliminate some parts, right? So, I mean, don't get rid of everything except the grid here. Otherwise, you'll have nothing to make. But relatively speaking, you can still delete and get rid of things that just aren't necessary to the project. So for instance, potentially that. Oh, well, don't get me wrong, I think that's a really great seat for outside, so I'm going to keep that one. But potentially I can make it better, right, and have it go right into this piece as well. All right, so what I'm trying to say is that you can still design this and you can still move things around and you can still chop them or put them together as well. So again, just want you to be able to know that you can still move these things around. Nothing's necessarily locked in or sacred yet. But let's keep going. So we got my pieces here. Man, that needs to go up. So let's probably put that up. To be fair, it might not work with this piece anymore. Potentially, I could move the whole thing. So let's take that whole thing. And let's make sure we got the whole thing. And let's just move it up. It's still on grid, and it's still working. Alright, so we're going this way, and that one might be a little too much. Let's get rid of it. And again, I'm kind of just doing this for the sake of tutorial, and trying to run into situations particularly that you'll run into yourself. And that's a big one, and it just kind of dead ends there. So, I don't know, I've been opening things up with a circle. I'm going to go with the rectangle. It just makes, I think, more sense there. It's going to be a little bit easier to build, so let's go ahead and do that. I'm going to make a rectangle. Just put it on the ground for now. And rotate it up. Although I can't really see it too well. Yeah, there it is, kinda. Get out of here. Boop. There it is. So let's get that piece, move it up, move it to the side. I kind of want to actually get the floor to chop through as well. That'd be kind of neat that it's more like a bridge situation, I think. And then I'm going to go at least 6 feet so that a person can actually walk through it. And just wire cut some of that piece out. So wire cut piece, and this piece maybe. Chop straight through it. I don't want to go up. Definitely want to go in my Y direction. Oh, not my Y direction, but my X direction. Sweet. Let's cut right through it. Awesome. So we can still shape this up pretty nicely. I'm not going to lie, that came out pretty nice. Pretty unique situation going on there. More or less, it looks like this thing either has to go up or down. I'm going to go with down today. And maybe actually make a copy. I mean, I can still design this for sure. And why not? We got unlimited material right here. So place that one up. And maybe make it a little smaller as well. Sweet. Let's keep going. Naturally, that's looking a lot better. I mean, we got some poles in there, but Walmart gets away with it, so I don't see why we can't do it. However, if it was absolutely in the way, again, I could take that entire grid system, right? Now, I did that, but I accidentally got a few pieces, so I'm going to hold Command or Control if I'm in Windows. And you can deselect something, absolutely. You can also just turn off the layer, by the way, right? That way you don't accidentally select something you don't want to select. But more or less, maybe I want to move the entire grid. So you can definitely do that still. So let's maybe do something like that. Sweet. And that works definitely a lot better. And hopefully you're seeing the potential of this. And again, I'm kind of moving all the grids at once. You guys notice that? Right? It kind of helps out at first. Don't get me wrong, you can still move individual pieces, but you want them to essentially be locked into the grid. Why? Because it's going to hold up everything. So you definitely want it to be in alignment. Otherwise, you got all these different grids going out. To be fair, we could do that, but it's just going to require a lot more finesse. But that's looking pretty good. Again, I'm going to turn on all my layers and keep going. So that's going to be a problem. It doesn't look like it can really go up and down without really changing the piece a whole lot, especially that really cool now seating area that I have. So let's open it up again. However, I'm going to open it up with something I already have. Let's open it up with what I just used. So I'm going to rotate that one 90 degrees. And as you can see, this one can take a little bit longer. But that's looking pretty sweet. Maybe up a little higher. And, oh man, that's really going to get rid of a lot. So let's maybe shrink it down a little bit. And of course, line that up a little bit better. Sweet. Kind of want to keep that wall going on there, so let's wire cut and go straight through with my Y direction. Sweet. I just need to go a little bit. I just want to kind of go through that first wall. I guess I got to go through the second wall, don't I? Well, let's go through both. So essentially we have like this little threshold now. Ah, man, it chopped off a lot. Let's see what it did. Not too bad. I still get that shape, and I can still walk through. Arguably, yeah, I guess that's okay. But let's get rid of that one. And ooh, there's kind of a Walmart situation going on here. So let's move that as well. And again, I can turn off everything essentially. To be fair, if I was much more organized, this would actually work. I'd be turning off everything, you know, it'd look all nice. But there goes the grids that I wanted. Bless you. But that way it can make it a little bit easier of a selection, right? Not too shabby. Although I still gotta undo some of those. However, you can leave some things grouped, and that will make some situations easier as well, at least in terms of selecting. Can't tell you how much time I've wasted in my life selecting things. But let's move that a little bit to the edge. Nicely done. Not too shabby, I like it. And let's turn some things back on. I think you can actually take a number of layers, such as all of those, and actually hit, yeah, nice. That is a time saver too. But let's keep going. I just went up the ramp. All right, this bottom section's really working out now. You guys see that? We've definitely eliminated, we've moved some things around, and let's continue. Because there's another one. To be fair, that one's a pretty simple fix, I think. I think I'm just going to move that one. Interlock a little bit with some of the other things going on over there. I think that's nice. And it's out of the way nicely. And it kind of locks into the stairs as well, so I don't know, maybe we can move it after all. Just a slight bit. Get maybe the rail in there. Not too shabby. So as you can see, you can move stuff quite a bit around. And it's actually making these pretty unique situations that would be hard to really design in the first place. And again, what's nice about this program is I didn't have to spend a dime yet, right? I'm just working in a three-dimensional space. But that's looking pretty sweet. I don't know how I feel about that just weird isolated one. Although it's kind of hiding that situation. I don't know, maybe it's nice. Maybe it grows on us, I'm not sure. Get back here. Let's obviously move that one a little bit. And move that one a little bit. It's still kind of sculptural, right? More or less. We're still sculpting things. We're still refining and all those kinds of things. So let's keep going. Dang, that's in the way. So another thing that we can do is actually trim off of another object. So for instance, I can take a three-dimensional object, type in trim, and as long as it goes completely through the object, and to be fair, I don't think this one does. Let's see what happens. Oh, it totally worked. Look at that. So you can totally trim pieces off as well. I don't know if we can do it from the inside. Let's see if we can do it from the inside. Oh my gosh, you can do it from the inside. How cool is that? But it got rid of the entire thing, so not exactly effective. Let's try that again. Another way we can do it is, of course, Boolean split. So if you say Boolean split, and we get those pieces, right? Obviously, we can kind of get the piece that's in the middle, and of course, get rid of the ones that we don't need. But that's if you actually wanted to keep the middle part, so maybe not entirely useful. Let's try that again. I think trim's going to be the one for today. Gets rid of the piece that we don't need. Arguably, it got rid of the whole thing. So what's going on here? Oh no, don't click on everything. Let's move it around just a tidbit, because you'd be surprised just moving things a hair. And to be fair, I don't think it's actually going to trim because, well, there's two pieces and it doesn't get the extent of that piece. If I did want it to trim, it'd have to be something more like, I'll show you. Let's get that one. Kind of hard to see there. It'd have to actually go through the object like that. So this should work. Let's try it. Trim. Make sure you click on the object itself. Nice. And it kept that bottom piece. Wonderful. To be fair, I could even take it a little bit out. That way I don't necessarily see it on the other side. However, it does look like it's kept some pieces there. That's okay. Can we see it in the render? That's the real test. No. Looks pretty good. Yeah, that render mode really makes it. Alright, we start to see the shade and shadow elements going on. I mean, that's a studio project right there, you know what I'm saying? How many times have you get to this point of a studio project and they're like, hey, we need some vignettes, we need some perspectives, and you're like, oh man, I haven't even finished my model, I can't take pictures of it. Well, now you have digital technology, to say the very least. However, let's keep going. Only briefly. I know this starts to be a really long tutorial that isn't necessary. Just to recap, we just need to refine the model. We need to make it work, right? If there's anything, obviously, you're not going to have the exact same situation. You're going to have different objects, but you should have the same categories, right? The grids, the objects, the volumes, and maybe actually some of the stuff that we've already done. However, let's move some of these back. Again, move face. So move face. I don't know if you can take multiple, actually. Let's see. Can I take multiple? I'm going to hold shift and see if I can. And it's like, hey man, which face are you talking about? Yep, that one. Oh, you can totally take multiple. Let's see what happens. Enter. It's like, what point do you want to take it? Right here. It's freaking out. Alright, let's see. And it worked. Very cool. You can take 3 at least when they're congruent. I mean, it makes a lot of sense. Those are technically the same piece that I had copied over. So it totally works. And, you know, I kind of like that. You kind of have to work around it. Anyway, I'm just kidding. Let's just move it. Sweet. I like that better. However, we're going to need something to hold up these stairs. So if you leave something potentially behind that can interlock and start to hold up these stairs, obviously we're going to put this together more like a puzzle piece. Obviously I want to make and complete the puzzle first. I want to chop pieces off the other. That way when I laser cut them or build them, that they interlock with each other, very much like the Japanese mentality. No bolts, no screws, nothing like that. Everything interlocking, of course, not in our case, earthquake resistance, but in their case, definitely because of that earthquake resistance. But let's keep going. And it looks like we have another grid in the way. Maybe instead of putting it on the outside, I want to put it on the inside. So let's do that for today. However, as you see, I have some stuff in the background, so maybe I want to go this way and grab that grid. You'll notice I go to the left, right? That way it only gets everything that is inside that box. I know I've said that before, but just to recap. Again, holding Command or Control if you're in Windows in order to deselect something from your piece. But let's go ahead and put that on the inside. I've been putting everything on the outside, so might as well switch it up. And it still aligns with that grid wonderfully. But again, I might have to move some things around. And, you know, potentially get rid of something as well. I don't know, I don't necessarily need that one. Get out of here. Let's keep going. Kind of like it. Don't mind it. Maybe it moves back just a hair. So again, kind of faking it till I make it. I kind of like that protrusion coming out. But the double layers is looking kind of weird. So maybe, I don't know. Maybe that goes up. Why not? Ooh, I kind of like it. It's almost too much. Let's see if we can work with it. Oh man, this grid is in the way. Definitely looks like it needs to go up. So again, let's take that grid. And let's not get this piece. I guess you can hang with this for now. Let's move that up. At least get out of the head space for this landing right here. And that's looking pretty safe, or at least safer. And it looks like it could potentially hold some of these objects in place, so maybe about right there. Yeah, that's looking nice. Bring that down and back. Alright. Wow, that guy's in the way. And he's in the way 2 times. Oof. Probably just get rid of him. Totally fine. Doesn't bother me at all. Probably take that one down a bit. Kind of like what it's doing spatially. Kind of like what it did for that area too, so I don't know. Maybe still leave it around. Maybe we rotate a little bit. Get out of the way. Ooh, it's not just gonna float in the air though. So maybe we bring it back just a little bit. There we go. Get a little bit of interlocking action. You'll see what I mean by that soon. Alright, so we're going up all the way. And that guy is still in the way. Whew. Maybe we just chop him off. Let's do it. Take him. We might have to take a few pieces actually. I think you can trim with multiple pieces. Let's find out. I don't actually know. Let's see. Trim. Nope, just gets rid of the whole thing. But it did try and go through. But unfortunately this piece wasn't going through that piece, so it has no way of knowing what part that I do want to trim. Then again, that was kind of on purpose. And it doesn't look like that piece really survives. Maybe we put it in there somewhere. To be fair, that's kind of just a random piece. Let's get out of there. But we're really starting to shape up. And as you can see, we see them really all 3 interlocking together. However, for the sake of tutorial today, let's get started on the next part and get to the laser cutting, right? Because we do want to make some of these pieces. However, one of the first things that everybody should more or less probably do is make this a little easier for our topography. I mean, how great would it be if our topography already had some of these cuts and pieces in them? Yeah, I mean, that I didn't have to cut these first by the laser cutter and then cut them again by hand just to get some of these circle pieces and components inside them. So actually what I'd want to do is subtract them already here in the first place. So let's go ahead and do so. Obviously the topography is what we'll be focused on today, at least in terms of the laser cutter. But at least in hopefully part 3, what I'd like to go over is unrolling the surface and laser cutting those pieces as well. To be fair, unrolling this is just an absolute mess. So we'll go over a couple of ways how to make stairs on both a laser cutter and analog. But for today, let's go over the topography. And one of the first things that we can notice, at least in a particular view such as X-ray or technical, is you can start to see that we have a lot of intersections inside of our topography. However, that is super confusing to look at, so I'm going to go back to maybe a ghosted, and that's a little bit softer, right? First things first, let's get some of the grid information in there. So let's isolate all of these. In my case, I'm just going to turn everything off except my topo. I make 2D. Sweet. And let's do one thing at a time. So like I said, we're still eliminating just because, well, I have a copy over here, so not really a big deal. And I just want to refine and refine and refine, get rid of all the things that I don't really need, and start to subtract from this topography. So one of the first things I can do is subtract from every piece. However, you're noticing that I'm getting a lot of pieces in there, so let's try and get that again. Let's turn off that topography, and again, get rid of just anything I don't need. And that looks like the gist of it. So let's get rid of that. Let's turn our topography back on and start minusing away. So in my case, this is definitely where I don't want to have these grouped, otherwise it won't work. And I'll get everything in my topography. And Boolean split, or difference, honestly doesn't matter in this scenario. But we'll take those pieces, those major pieces anyway. It looks like that's about it for major pieces. I think so, yeah, major piece. And let's get all of those topographies. Enter. That might actually take a second, but it looks like it did actually work pretty quickly. But we don't need this sort of inside piece, and I know it's kind of hard to see, but that intersection piece obviously doesn't really exist, or we don't need it to in reality. So let's try and subtract it. Oh, it looks like it didn't. It's still one piece. So let's see what happened. Let's try something else. Let's try our pieces first. And, you know, if it doesn't touch, it doesn't touch. It's just not going to work. But, you know, for the sake of clarity, we'll unselect those. But for instance, like that one, it's just not going to do anything. But I want to keep those in there. And Boolean split. Man, why won't it keep my split? Let's try that again. Let's try difference, because I am subtracting. There we go. It should keep that selection. Hey, you know what? Let's try it all at once. Why not? If it doesn't touch, it's not going to touch. Enter. Ooh, I think it did something. Let's find out. Ooh, Boolean difference failed. But why? Now, to be clear, it's usually because I'm trying to do multiple things at a time. So, well, let's try it one at a time. Sweet. And let's go with Boolean split and just do one at a time. Oh, wait, it did split. Look at that. I don't need that piece. Don't need that piece. And it actually got rid of my topography pieces. Hey, what do you know? It actually worked the whole time. My bad. But it definitely left over some pieces that I don't need. Right? Actually, quite a few of them. Not sure why. But there's the actual piece that I do need for my laser cutter. Right? Potentially the one with the circle cut out. Right? Definitely want that because potentially I can lock these pieces in together almost like a puzzle piece rather than, again, having to just cut and isolate every single piece. However, I want to do that to everything, so let's go ahead and do so. And make sure that this... Oh, I think it did actually work. There we go. Let's get rid of some of those pieces. Keep in mind that when I did that Boolean split or difference, I can also delete the input or delete the after part, so I can avoid this step altogether. However, I'm kind of doing it today just so that you can kind of see what happens. Obviously, it's going to make a leftover piece, and it's going to leave a cut for us for that topography. Super important there. But yes, I do need to kind of do that for essentially each layer if I didn't check that option. So yeah, there might be multiple in there. And it looks like we're good there. Both pieces looking good. Let's check that one. Yeah, both pieces looking pretty good. Let's check that one. And yeah. Oh, nope. Yeah, looking pretty good. Let's make sure it got this piece, 'cause I didn't see it actually get that one. Oh, did it? Dang, nailed it. Nice. And I guess it didn't actually go down that far. Or maybe it did. Did it go down that far? Ooh, it tipped it. That's why it's like a little bit. But yeah, again, that ghost mode, super helpful in being able to see inside this project right now. And it definitely cuts through that one. Sweet. I think it cut through the second one as well. Nice. All right, so it looks like we got the major pieces, so I'm going to turn off major pieces. Sweet. Let's turn off those. Next, let's get my grid. Obviously, I'd want to put my dowels in as well. How super simple would that be? All I have to do is buy the right size dowel and just stick them in there and glue them down, right? To be fair, I guess I could just poke holes in my cardboard as well at a specific rate. But who's got the time? So let's do that again. Same piece. To be fair, it looks like I'm getting a little bit of that background piece, which is why I'm kind of turning my model a little bit. Make that easier of a selection. But that's looking pretty sweet. And now let's Boolean split or difference. Let's try difference this time. And get all of these horizontal pieces. So boop. Nailed it. Enter. Ooh, chopped it right off, but not in the way that I wanted. So let's try that again. Usually you select what you want to subtract from first. So Boolean difference. And it looks like I had something checked. Oh, delete cutters. No, don't. Hey, don't delete the input. There we go. So my input being, of course, this piece. Nice. We don't want to delete those, so keep them. But we don't need those little pieces that it created in there. Ooh. Did it make a hole? Let's find out. Oh, I think I accidentally undid it. So let's redo real quick. Ooh, totally made the hole. Sweet. And that's exactly what we want. And I think it actually deleted the little piece. Let's find out. So let's turn everything back on. That way I don't accidentally move things around or anything like that. We'll turn our walls back on. And not looking too shabby. It's looking about the same, more or less, right? But now we can kind of see what's going on. But let's take that topography. I guess I spoke too soon. Let's turn those off. Switch to topography. Nice. And it looks like we have a leftover piece in there. Sweet. But more or less we should end up with something that kind of looks like this. And we've still got some leftover pieces we need to delete. If it's a little bit easier. That way you can kind of see the holes going on in there. You can kind of see it. Let's go back to a shaded view, see that a little bit better. Probably, yeah, there we go. Still got some pieces in there. So we need to get rid of those. Obviously not the whole piece, just the piece inside. All right. Yeah, see what I mean? Now we don't have to do any of that work. Obviously we'll do it here, but now we just laser cut it and put it together like a puzzle, which is super helpful and normally referred to as digital design and fabrication. Right? The way in which we fabricate something, especially today, we make them in the computer first with all the tolerances and all those different things. And then quite literally we 3D print them now and prototype them and do all kinds of things. However, I would say this is the very basic first step, right? Creating a puzzle and using this methodology of creating a puzzle, not necessarily a model, right? But again, figuring out all those things and viewing it in the right way, looking at the shade and shadow quality, all the stuff that we would do to a normal, real physical model, we kind of have to use this simulation in order to do so. However, we can save our hands and our X-Acto blades, right? And we can make it a lot more accurate. However, from there, let's get ready for the laser cutter, as we have about an hour until Professor Ball's class gets in there. So more or less, it looks like I have some things left over. Maybe not. It looks like there's something in there. No? Either way, that's totally fine. I just need that circle there because I'm going to make 2D with all of these. So let's take the whole thing. And like I said, let's make a copy. So let's turn everything back on. as I mentioned before. Boop. I'm going to turn that all back on. And actually, I guess I should have got the copy first. Either way, that's okay. Let's make a copy. I'm going to take the pieces we need and start making some laser cuts. So let's go to my top view. And I think that's my copy. So, or that's my copy. Ooh, see? Very easy to get confused. So I'm going to place this somewhere important. Go over here. And we don't really need that guy anymore, so let's get rid of him. And a little bit more organized. And there's the one that I'm working with and that we want to use for the laser cutter. So I'm just going to go ahead and hide the rest of that. Sweet. So for the laser cutter, obviously I made a copy of these, so I don't really need that part or those parts. And I really want to remove each layer at a time and kind of in a methodical way. I accidentally moved my top plane. That's okay. Switch back to top. Sweet, much more isolated. But let's take that out of a shaded view, go with a wireframe, and see that a little bit better. So obviously getting rid of all the things that I don't need for this next part. And really all we need to do from here is take each part and make 2D. So again, one layer at a time. And sometimes I like to do that first. So each layer. And you might need both views for this. That way you can kind of see what you're doing. Doesn't really need to be at a similar height or anything like that. But more or less we want to make sure we got every piece and that they're of course correct as well. Let's isolate that a little bit better. Nice. Good deal. Oh, almost forgot the top piece. And again, I kind of want to rearrange it here just because, well, as long as I don't mirror them, technically, I mean, don't get me wrong, we have a situation on the laser cutter to where if I mirror it, I'm actually making the piece upside down. Does that make sense? Right, because I can cut it and I can use the bottom. So, I mean, there's definitely some interesting design principles that we can really use with the laser cutter. However, for today, let's keep it simple. So in my case, what I'm doing is actually called nesting. Trying to maximize the amount of material, that way I don't have a lot of waste. So in my case, kind of nesting them up a little bit to minimize that waste, but potentially literally just getting all the layers I need. It does kind of look like a face. And of course, when you have thousands of these, by the way, you do want to keep them in particular orders. So there is that. But obviously just getting the pieces I need and verifying at the same time also what pieces got cut out. I may still have to go back and cut some things. However, once we make 2D, it's kind of free game, right? Because, well, you can always change the make 2D lines. I don't necessarily have to remodel it again. But yeah, this is a little tedious. And I can't wait until AI takes my job. No, I'm just kidding. But again, I'm not just moving the pieces, I really am looking at each one and making sure there's no kind of strange anomalies or seems out of place or something. Like one's missing the shape. In my case, it looks pretty perfect. Doesn't look like anything's missing. Until I spoke too soon. Ooh, looks like the wall might be missing. That's okay. These are the bottom layers, so maybe they don't actually go into that piece. And that could just be actually a leftover. Yeah, it's a leftover piece. Yeah, that's what I thought. But there's our bottom layer, and it gets the circle. But instead of doing this one at a time, it makes a lot of sense to kind of line them all up first, take every piece, and make 2D. But, you know, back in the day when I was a student, I would have sat there and made 2D with each little piece, right? Not knowing that, of course, I could just do it all at once, make 2D, bam, there's all my laser cutting lines. Done, right? Down to the very T. Ooh, interesting anomaly. Kind of a Vesica Pisces. I wonder which one's the correct circle. But clearly that can happen too. Oh, that's right. I was testing a bunch of different profiles for you guys. So that totally happens. And in my case, you'll see what it does on the laser cutter today. So we're going to definitely maybe not cut out every single piece, but we definitely want to cut it out. So, what scale is this model? Anybody know? 1A, thank you. So I need to calculate it for the laser cutter. Now the laser cutter bed, at least upstairs, is a 12 by 24. That's great. And it's essentially just a piece of paper, right? It really is a printer, except instead of ink it's printing lasers, which I don't know what could sound any cooler. But in our case, we have a limited area, and we do have to stick within that area. If it's outside the area, won't cut it, right? So it literally has to be in that area, or it literally won't even cut the whole line. Say there's like a tiny millimeter sticking outside of the border, and that whole line is connected to the inside of the bed. It'll literally just not cut the entire line because a small millimeter was outside of the proportion. That's definitely important, right? Because you'll cut your entire thing and go, why didn't it cut some of these lines? And it looks like it is exactly at the border. And if it's not, it won't cut. So since this model is at 1:1, so for instance, if we do DIM and verify the dimensions, we'll find that, oh man, it's actually 48 feet. Well, if I cut 48 feet, it's just gonna not even cut. Actual size, I mean, that's literally the size of this building. Anyway, well, maybe not so much. A little bit of this floor. It's a large swath. Anyway, in our case, a couple of things that we want to do first is scale it. So I need to make a rectangle, and I need to times it by the amount of inches that are available within that piece of paper. So the trick that I like to use is, well, since I have a 12 by 24, I'm going to do 12 times 8, which is 96. So 96 feet. And in my case, 24 times 8, which is 192. And there is my bed size at the correct scale of this 1:1 piece. Now, as you can see on my laser cutter sheet, it's not going to fit every piece. I mean, that's just kind of pretty obvious, right? However, it's going to fit most of them. And to be fair, there's a couple of things I can do with the laser cutter. The first thing is, of course, not keep everything in purple. So the first thing I want to do is actually have a cut layer, which is blue. And it, not off blue, not dark blue, but literally exactly blue. Keep that in mind. Definitely important there. The next thing we want to have is a score line. And I usually do it in all caps, just, you know, for clarity. But it does need to be a red line. And to be fair, in some schools that changes. Even my laser cutter can print like any color, whereas our laser cutter upstairs literally only cuts these two colors, which is unfortunate because it's also the most expensive out of all the machines. Our laser cutter, about 30 grand. My laser cutter, about 4 grand, and it's twice the size and 4 times the power. So things are getting better, right? To say the very least. That's an old machine. But in our case, I might actually want a layer that's no cut or nothing, right? And I usually leave that black and set that layer. Nice. That way it doesn't either cut it or do anything to it. It's just kind of a reference layer for us, as you'll see when we go upstairs. So let's take that piece, and you know, honestly, I don't think I need all those. And by default, it's grouped, so I want to ungroup that first. And actually, I don't think I have any scores here, but for the sake of tutorial today, I do want to show you what the score does. So maybe that one's a score. Well, in my case, let's do this first. Turn all of this into cuts. Sweet. And let's turn some of these into scores, just for the sake of, you know, showing you what it does. And let's say I was lining up my piece to a part, and I don't necessarily want it to cut through, but I wanted to line up maybe one of my gigantic circle dowels or the thing that I'm creating to line up to the piece of another piece. Definitely understandable. But one thing I do want to mention is that you can use your points, right? And that is exact, which is, again, why near is so unforgiving, because near will select literally anything, right? Also, I'll turn off center and near in this case, and make sure that I click exactly on that line. What's nice about that is, in our case, especially with the laser cutter, I can go over another line, right? And I can fit these two pieces exactly. What's nice about using the scale of 1/8 and 48 by 48 is that, well, technically 8 pieces should fit, right? Because they should be all 6 by 6. So in my case, I'm going to move those. Move. and I'm kind of moving them onto this page. That way I can make sure that I eliminate them as well, and that I don't accidentally make 2 pieces or accidentally miss one, right? So instead of making a copy, I'm literally taking that one, right? And seeing that it lines up perfectly. I can zoom in forever. That black line is never going to be on the outside, right? In fact, we really can zoom in forever. It almost gets ridiculous. Zoom out. Anyway. You'll reach a point of no return, by the way. You'll be like, am I zooming out? Am I zooming in? It gets weird. But I do want to line up all my pieces, essentially. And really, this is for the sake of tutorial. I'd want to select points I know. In my case, obviously, you can see that I'm sticking with that overall rectangle and lining up to points that are already within inside that rectangle. But more or less, that would be sheet 1. So that's going to be my first job and my second job, right? So this is only going to take 2. And to be fair, let's see how well this fits. I know it's not going to fit. But for the sake, let's join these back together. That way I don't accidentally lose some pieces. I guess I should have done that to the first one. But you could also group them again. Group doesn't affect the laser cutter, so you should be okay there. So if you do want to group each of these pieces, say one at a time, that way you don't move or accidentally skew all the little holes that we're going to make. Definitely good. You'll see what happens when you accidentally skew those holes. That one piece will be completely out of alignment with the rest, right? See, that's where near would actually come in handy there. Sometimes you do need near, not gonna lie. But for the most part, that looks like. However, another thing that we could do, guys, is some of these pieces are gonna fit actually right there. Now that still works, right? It's not gonna cut into another piece. In fact, it uses my X material to actually cut it. However, what if I accidentally do this? It's going to cut a hole in that piece. I definitely don't want that. Now, technically, I guess we won't see it because another piece will cover it. But it won't cut out in the way that you want. And I do like to make that point because I do end up answering that question every year. Sir, why did my piece cut accidentally out of my piece? Well, you lined up the piece, Julie. Anyway, I don't know any student named Julie, by the way. So that's why I use that name. But that would cut it pretty successfully as well. To be fair, we could get really, really close. In fact, we can get 0.001 of a millimeter close. That's how accurate this machine is. So yeah, that, no problem. Now, is it going to maybe burn the other side of the other piece? Yeah, maybe a little bit. So, but I do want to save on my material because at any other school, in fact, they might actually say, hey, we're not going to cut your piece because it's not efficient enough. And that is exactly what they mean by that. Well, how much is a waste to cut ratio? And that's exactly what they mean. Did you actually nest your parts as efficiently as possible? That way you can eliminate the amount of waste that you would use. Oh, this is what I mean. Don't accidentally not get these pieces. Ooh, I don't know if I accidentally got them of another. So again, be very careful. I don't think there was actually any in there, so I think we're okay. To be fair, that would be cut, right? No alignment, no crossover, we're good. And for these, the last couple of things we need to do is actually set the layer. And we could have done that first, but it's not a big deal. Make sure that when you actually click on the layer, if you scroll a little bit, you'll see a print width. Now, we can't just use the default on there, so if you double click, we need to use hairline. So make sure you set it to hairline, which is 0.0001. Apply. And we'll do that to the score line as well. Apply. And that's pretty much all we need. From here, we'll export it as a DWG, or honestly, we can export it as a Rhino file. However, the Rhino upstairs is Rhino 6. So it's not going to open up a Rhino 8. However, it will open up a DWG. It will open up a Rhino 6 file. So let's file export selected and make it either a DWG or a Rhino 6 file. So we'll save it as a Rhino 6 and we'll call it test laser cuts for today. That's hilarious. Anyway, we'll put it on the desktop for now, and then I need to, of course, put it on my USB and go from there. Any questions? So welcome to part 2, right? Obviously the laser cutter part. It's kind of a big deal just because normally, guys, you don't even get to ever touch the laser cutter. Honestly, at any other school, it'll be the operator who basically does all the touching, right? For the most part, what's nice is that you know that how the machine works, and well, at least at San Antonio College, you're allowed to laser cut yourself. However, it does come with some safety, right? And obviously, I want to cover that today. That way, you know what to do if something does go wrong. And you know the right operations to, of course, not only keep yourself and others safe, but make sure the machine remains not burned, right? Obviously, we had an incident last time. That probably goes, unfortunately, it was a student who didn't get this training and didn't even watch my free video, right? Of course, this kind of sets to update it because the last video was honestly at the CAC building and it was a little bit of a different layout and things like that. However, honestly, it's about the exact same with the video. And I misspoke earlier in the video. I said that blue was cut, so I ended up actually just switching those real quick. It's red that is cut and blue that is score for this machine and this machine only. Not a big deal, just switch the colors, right? All the other things remain the same, such as setting the line weights to hairline and all those kinds of things. But to be fair, once we open up that file, and it does open up pretty slow, give it some time. I'll keep Rhino 8 open, but one thing I would say about this computer in general as well, don't restart it. Don't turn it off, just let it die, right? Anyway, because it is one of those old computers that honestly takes longer to load than it does to like the amount of time you actually just need to use it, right? So, but that being said, I opened up Rhino 8 and I'll basically just keep that open, but just for the sake of the video, you'll also click on UCP, double click, and that really is the printer apparatus. Some of the things that you can note here is obviously the viewer, where it shows us kind of the visual representation of that. We have the system settings, which you never have to touch, and diagnostics, and again, you never have to touch those things. So again, we have the viewer. We have the file itself, and as you can see, we have 3,975 files. There's a lot there, right? That goes all the way back. That's every cut that's essentially been done on this laser cutter. So again, once you send it, it's kind of hard to take it out. I would say don't try to delete it, like nobody's going to come and like find you. But one thing could be said, you see how this one's labeled X? Foodwood Halls, Model 1, Capstone, Lazar, Capstone, Lazar. It's just kind of the same thing. I want to see some better file names from here on out. In fact, I'm going to start requiring that you at least put your last name at the beginning, underscore, and then the file name. Because again, we need to start being more accountable for this laser cutter. Now, no, that doesn't mean that just because this gets burned or broken that even that person is liable. Even the person who broke it, who wasn't even supposed to be using it, to be fair, just a slap on the wrist. Luckily, we had grant money available and we were able to repair it for $2,800. But again, it might not go so swiftly the next time, right? Obviously, they were at fault, but they didn't burn the building down, so I guess that's good, right? However, keep in mind, you want to put your last name, underscore, and then the file name. Again, we just want to be able to know who is here. That way, if somebody that even is outside of the College of Architecture trying to use it, we could easily identify them. Hey, you didn't even put your name right. We know it was you. Those kinds of things. So it's kind of more of a protection for you and the others around you, and more specifically the machine. However, really, it's pretty easy. And remember how I was saying that rectangle is so important? Because again, it controls the paper size in a very literal way. Now for this machine, it's kind of nice because it's essentially a printer. Mine doesn't actually work exactly this way, but it's not a tutorial about mine, it's a tutorial about this universal laser system. So the first thing that we're gonna do is make sure that we have a 12:24 ratio. And the reason I say ratio is because this machine doesn't require exact dimensions. In fact, it works like a printer. So it works on basically the print file, or the PDF, if you will. And you know how the PDF is just one size? You basically decide what the paper size is, and that's about it. So in our case, we'll go to File Print, just like if it was a printer. And we'll not select Rhino PDF, and instead you'll go to this really weird name called VLS 3.50 whatever, right? To be honest, once I click it today, it'll go back to a default of, again, this 12:24 piece paper. It even kind of shows you that preview because, well, that's the only size paper, really. It's always going to be 12:24. Even if your material's a little bit smaller, it's still going to print 12 by 24, so that's important to know. And you can't really change that anyway. The second thing to go to is, of course, view and scale, or the view output scale. In my case, I'm going to select window. Now that's really important because now I have the window that I need. In my case, I want to make sure that I have endpoints checked. I want to select my endpoints and basically tell it that frame, and it's going, hey, do you want me to use this area? Are you trying to match that up? Hell yeah. I'm going to hit yes and enter. Naturally, you should see the exact same formation and the exact same ratio. If you see something that's small or too big, that is not going to print right. This is the actual scale that it is. In fact, you'll see that, in fact, it's disregarding the scale completely, and it's going to that window. So again, as long as that's 12 by 24, not accidentally 12.2 or 24.5, right? It really does have to be that exact ratio. It could be 12 feet by 24 feet, right? Again, you can still do your scale tricks like I've taught you, and you can still use this method specifically for this laser cutter. However, once you're done there, we'll press print, and absolutely nothing will happen because we have to go back to that universal, right? So we'll minimize that one. You'll give this a second, and voila, it'll load that preview of the file that we have. Right, this is kind of like our print preview, if you will, before it goes to the laser cutter. And as I was saying last time, remember that the this, what is it called? UCS? UCP. Not the greatest acronym, but okay. You do have to make sure that it's clicked open in order to turn this on. So the first thing that you'll do is, of course, hold the power button. It'll turn on. You'll hear it kind of do like this 1996 AOL signing on to the internet sound. And what that's doing is, of course, calibrating. Just to go over what I was going over last time, obviously we have the laser cutter bar, which is known as the X bar, and the Y bar, right? Obviously we have two bars on the side. This is the actual laser cutter lens. So the way that it works is a CO tube in the back, and it shoots a laser and it hits a mirror. It hits this little mirror right here, right? And of course that little mirror goes to this little mirror and it shoots it down. As you can see, there's kind of a hint of a red line there. Keep in mind that if these aren't clean, they don't cut very well. And also if you see happen, well, honestly, you shouldn't pull this out like I did because putting it back is very tricky. It is quite magnetic, so you really can't go wrong. But one thing I would say is that little lens right there is about $320, so don't scratch it, don't drop it for the love of God. However, if you happen to have Q-tips and some isopropylene alcohol, such as fingernail polish remover, same thing. You can wipe that with a Q-tip, and you can usually clean it off pretty nicely and make it stronger. The same thing can be said for here, where you see a 2.0. That 2.0 stands for 2 inches from the bed is the perfect autofocus. That's what it stands for. So the tip of this edge of the red right there needs to be exactly 2 inches from the top of the material, not the bottom. And of course, I've made a little apparatus to show you what we're going to have to do. So once we have the file there, and once we have our wonderful piece of material, which today hopefully will fit, I think. This should be okay. It's not going to get all of it, but that's fine for today. I'm going to want to line it up to my ruler, and to be honest, by the time of this video, and probably by the time that you guys use a laser cutter, I'm going to change this plate. Honestly, it's not supposed to be this plate, and the reason it's aluminum is because lasers don't go through aluminum. It's the only metal it doesn't go through. In fact, aluminum is so reflective that it bounces off the laser completely. For extra credit, does anybody know how we cut aluminum? Bless it.
Thank you.
Water cutter. So instead of a laser cutter, we use a super high density water jet, right? That basically cuts large sheets of metal. And if you're driving a car today, you probably had one cut with a water cutter, right? So interesting enough, these machines have been around since honestly the 40s, right? However, now it's starting to be applied to architecture in terms of construction. Computers are starting to get better, and honestly, these machines are starting to get more and more accurate. What better way than to have accurate architecture in buildings by, of course, assembling them, making puzzles, right? For the lack of a better word. So we'll line up our material, make sure that it is lined up to these two bars. That is definitely important. And to be honest, this is a pretty cattywampus piece. I'm gonna try and use that 90-degree angle. This is also known as our 0, 0 point, right? Which is in that top left corner. and you want to get it as far in there as possible and as flat as possible. If you have some sort of warped image, why does that not work? Right, that laser has to be exactly 2 inches, and if the board is warping even by millimeters, it's no longer 2 inches. Again, it almost works like a sword, right? And at that focal point, if you've ever been the guy to like magnify ants, you know that very well that at a certain angle it doesn't work. Excuse me, that's what I get for claiming that I killed those ants so long. But it's that focal point. Right, so obviously the laser can't be too far and the laser can't be too close. It's gonna cut just right at a certain area, and that happens to be exactly 2 inches. So now that we have our piece there, sweet. The next thing that we need to do is, well, put the laser over there. I mean, right now the laser is on the bed. I need it to be over the material so that I can get 2 inches over the material. So first thing I can do right here, and it's kind of a weird symbol, but right next to this magnifying glass, which by the way means, you know what it means, you can zoom in. If you hit this one right next to it, it's known as the, oh, I guess it doesn't have a name, okay. However, you'll see immediately an X and Y grid, and you'll see where it's at right now, which it says that it's at 0, 0, but that's not the case. So in my case, I'm gonna go to the middle of the material, or where I'm about to cut. And of course, immediately you'll see the laser move to that exact position. So that's kind of a game changer, right? I mean, especially if I'm trying to find if certain pieces are maybe outside the range or the extents. So for instance, I open this up just to kind of show you what it's doing. Make sure it's always closed before you click anything, right? The reason I say that is because it can bend itself, right? It doesn't know that it's open, right? But for instance, I'm kind of curious. I don't know if I'm gonna get this line down here. So I'm gonna click on it down here and go, uh-oh. Let's see if I got it. It's not going to reach my material. In fact, it goes way off base. Right. Another thing to do is, well, make sure that it's at 0, 0 as well. And as you can see, it's not even at 0, 0. So this entire plate is actually slightly off. That's not good. Let's see if I can fix that real quick.
No.
Let's home XY. There we go. So it's basically just going back and forth. And what we're trying to get to is that 0, 0 point. So let it do its thing. It's going to go all the way across. It's going to see its extents. And so hopefully you saw that I clicked on the home XY. Right, not home Z, because that's going to make the board just kind of infinitely do something. So stop that if that actually happens. But we should be good. Oh, still thinking? Oh, it thinks the home is over there. Interesting. Well, that's not good. Let's see what 0, 0 brings it. Okay, so it definitely knows where it's at. It found that 0. But it can't seem to find the top 0. I got an idea. I think it's just off. Let's try homing it again. After all the fixing and the shifting. Now it's on track. But yeah, I definitely want to show you that kind of stuff in the video too. Now that's a last resort. You really shouldn't push the bar, especially while it's on. However, if it's not really running, like while it's moving and you try and move it, that would actually break it. Right? But in our case, let's try that again. 0, 0 point. Nope. Still in the wrong spot. Okay. Well, we'll have to figure out some bugs. But in my case, I'm going to line up my material to that 0 point then. Sweet. So next thing, we still got to click on the material. And we still got to use this guy. Now the way this works is essentially you want this bottom little ridge, if you will, at the bottom of this horizontal line, right? So at the bottom of this red plate, right? And obviously the bottom of this with the bottom of the material. So right now, and you might want to get a little bit closer, like right here. So for instance, some of you guys may be able to see, probably not where you're at, but you might want to see that there's two different two different flushness, right? There's definitely a dip in there. We want to get it perfectly flush with that red plate. So as you can see here, it is not flush at all, right? So in my case, I got to bring the bed down. I'll use this down arrow. Pull it down a little bit and see if I can get it flush. Right now, it's perfectly flush. So I'm going to lift it up just a little bit until it pops off a little bit. That way I know it's exactly 2 inches. All right, so again, don't lose this, by the way, because I'll have to 3D print another one. But that's looking pretty good. Last thing, I'll close it. And of course, close this. The thing about this glass door as well is if you open it, it will shut off the laser, right? So if there is a fire, I know it sounds completely unintuitive, but if there is a fire, open it, because it'll immediately stop the burn and the laser from running, right? Again, that's why there's glass here. That way you can see if there's a fire or not. Now, why these 2 students that burned it didn't notice is because it was probably 4 o'clock in the morning. They were half asleep. Luckily, though, at least one of the students was here, and he just noticed a bunch of flashing. So he immediately tried to turn it off. Luckily, they didn't pour any water on it, because usually that's somebody's first instinct. For the love of God, please don't just pour some water on it, right? Or dirt or anything, right? If anything, obviously lift this up and unplug it, right? If that would be the scenario. Now, hopefully none of you actually have to go through that. And of course, if you're watching this, again, definitely review, because you never know. And like I said, you should be always with a partner working with this anyway, so there goes without question, right? However, once we're all finished, we gotta go to settings. And to be fair, this is usually not this long, I just talk a lot. We'll go to the materials database. In our case, we do have cardboard, and you're not gonna necessarily see something that says, hey, this is cardboard, right? However, there are things that are natural, right? Such as mat board, or chipboard is another way of saying mat board. And you'll see that we have a couple of things here, like obviously cork board we can cut, mat board, paper, stone. To be fair, it's not gonna cut through stone, it's just gonna like etch it, right? Some of these things, they'll etch them rather than actually cutting through them. Keep in mind that this isn't the strongest laser cutter, it's about 30 watts. And to be honest with you, the most that it can cut through is like maybe 5 millimeters of basswood. And even then, it's gonna cut super duper slow. So don't count on like 1,000 lines the night before your models do, right? One thing I would say is, especially with the laser cutter, it does cut things really well and accurate, but at the same time, it's not always making a finished product. One thing I would say is that usually you want to sand down basswood once it's cut, otherwise it looks pretty black, right? You also want to sand the top and the bottom because they'll be burned a little bit. One thing I would say about museum board, chipboard, or any other boards or acrylics, if you tape them first with matte tape, there's no burn marks. You do your cut, you take off the tape, and there's no burn marks. Again, that's a huge plus that not a lot of professors go over. They let you kind of discover that on your own. However, you tape the front and the back, especially that white museum board. You're trying to get it crisp, clean, clear, right? So again, you'd want to use maybe that blue painter's tape or even just your regular drafting tape. Again, more like the 3 inches. Don't sit there with like the really thin stuff, right? You also don't have to do the entire board if you're just cutting a small portion out of that piece. So do keep that in mind. However, for today we do have cardboard, so I'm going to select the mat board. And it's probably about 1/8 thickness, so I'm going to give it a thickness of 0.125. Keep in mind that it is in inches, so you will have to put it in inches, not necessarily something else. Sometimes I'll add a little bit of thickness, especially if I want the power to be a little bit stronger. So again, 0.13 is probably definitely safe. In my case, you'll see that we have our colors set here. So raster is black, vector engraving blue, and vector cutting in red. So again, definitely, we don't have any blue for today, so that doesn't matter. But very often I like to add about 5 to 10%, right, to my cut to make sure that it does actually go through. One thing I would say is it's okay to have like a little test piece and test like just a cut line to make sure that it's actually going straight through the piece. There's nothing like going through an entire cut to notice that it didn't even go through the page. You know what I'm saying? If that is the case, don't move the material a bit. Press play again and let it roll the exact same cut. It will roll the exact same cut. However, if I accidentally move it, or when I'm checking the material, I move it or slightly change it, I can't do that. I can't just press play again and it magically hits the same line. It's actually gonna make this weird kind of double clone image, right? Which you definitely don't want, and it'll definitely ruin the material by then, right? However, once we're done there, we'll hit apply, and we'll press OK, and we'll press play. Well, before we press play, we'll ask Patty to turn on that switch, if you can turn to that switch that we see on the wall.
The vent,
The
is it
vent.
connected?
Should be.
Well,
Oh.
there's a vent too down there.
Yeah, it's kind of connected. Don't get me wrong, we probably shouldn't get that on the video, but yeah, it's not the best connection in the world. And to be fair, it is probably a good idea when you are laser cutting to leave the door open like that. However, if there's nobody in here, what do you got to do? Close that door, right? Just because we definitely don't want anybody to mess with this machine or hurt themselves doing something that they have no business doing. Also, the fumes are pretty bad, right? So, kind of want to give yourself some ventilation. It's not that bad. You don't have to move. We're only going to cut it for like 30 seconds. But, when you're cutting and you're going for hours and there's tons of models going, it starts to accumulate, right? However, we're going to press play. And you can totally watch the laser from the top, so if you want to get a nice view. And we'll press play. See how it's smoking a little bit? Totally fine, but there should be some better ventilation. To be fair, it's probably fine for our project, but yeah, not the best ventilation. It won't hurt you, it won't cause a fire or anything like that. And to be fair, that's not even something to be like super concerned about. Eventually, once it's finished. Now, I do want to pay close attention. You see how some of the flames are coming out of there? That's okay. Now, if it's a steady flame, that is not okay. And again, you'd want to open it up immediately. But it's burning. And it is paper, guys, right? I mean, it's like somebody coming in with like a sword. It's getting those little squares. That exhaust is abysmal. Hold on. Better. Oh, that's oh.
Yeah, I think that's supposed to.
Yeah. You didn't even put it back
No wonder.
better.
Starting to clear out, yeah.
Better. Anyway, so once it's finished, guys, obviously in this case, yeah, make sure the exhaust is actually connected. I think in this case, after the repair, you didn't put it back on. But as you can see, they got all the cuts. Only because we moved the board. Definitely not too bad. And it did cut straight through. Kind of lucked out on that one. That's cool. And there's my piece I need. And as you can see, yeah, it does make things pretty easy, doesn't it? Yeah. Cardboard's pretty good. It doesn't burn too badly, at least on the sides. And honestly, I kind of like the smell. But yeah, definitely works just fine. However, that was with an extra 10%, by the way. You'll see that it does cut into this plate. Again, I'm going to replace the plate with that fancy grid. However, it comes all the way from China, and it does take a long time to get here. But yeah, once you're finished, obviously you pop out your pieces. And again, if you notice a lot of struggle with this is pretty healthy struggle. It should be a little bit of a struggle. You don't want it to just fall apart because usually that means it wasn't so accurate either. Another thing to keep in mind, guys, is look how thin these lines are. That's actually what you want. That means we had a good ratio of that cone. If it's too thick, that means you got a big portion of that cone, right? Whether that was too close or too far away, right? So I definitely want to point that out. Because some of these things you can kind of just tell. I mean, that's a beautiful cut. It's very clear that they just repaired this and they just cleaned it really well, right? It's got a nice thin line, things are popping out, and you see the cut on the other side, right? That's a good sign too. Now that one's pretty wonky, not gonna lie. But it still pops out, and cardboard's pretty forgiving like that. It's paper, so it's gonna naturally kind of rip a little bit. But again, this should be definitely enough information to get started, right? However, once you're finished, you want to leave this place better than you found it, right? So of course, close it back up, and you can leave it on, right? Totally fine if you just leave the system up and running. So, other than that, any major questions? Nothing. Excited? Don't burn yourself. Obviously, it's a pretty awesome machine. It can save you a lot of time. But also keep in mind that it takes a lot of time to set up. So again, you have to be you're either spending time in one area or you're in the computer setting up files and getting ready to print. Those kinds of things. Oh my. Anyway, we'll leave it there for today, at least in terms of the physical laser cut video. Let's head back to the classroom and go over kind of the second part. I want to show you some more than just topography. And let's record. Alright, so to continue, we just got back from the laser cutter and we just cut out some of these pieces, and as you saw, it cuts out really well, right? Especially for cardboard and really a lot of paper-like materials. What's really great about that machine is you can cut like regular printer paper, so you could potentially print something that you want and then laser cut it. I've made some of the greatest pop-up cards that you've ever seen, right? My wife all the time is just like, how did you do this? You know? And it's because I have a laser cutter, right? And it very often looks very professional, very perfect, right? And it is. It's down to the, super accuracy. To be fair, you start to realize that cereal boxes, stamp machines, everything that you see in the supermarket is essentially cut first, flat, and then folded up. So again, I want to continue this methodology because it's not brand new. It's maybe brand new to architecture, however. Right, because normally we would actually cut standardized pieces like 2x4s or 2x6s, and we'd make it the way that we want to. But now we're becoming able to honestly control robots. We're able to actually have 2 robotic arms make the material for us and do something that's maybe even hazardous to a person. So I do think it's pretty crazy. To be fair, Japan is already making skyscrapers completely autonomously, where essentially robotic arms climb up the entire building as it's building it. You know what that means? 0 people dying for the construction of a skyscraper, which on average is usually about 100 people per skyscraper. It's pretty sad, and it doesn't usually go in the news so much, but building buildings is really dangerous. And to be fair, manufacturing in general, I don't know about you, but I've seen some terrible imagery on, deep web stuff, but of people being in the wrong place at the wrong time in a factory setting, like it does not go well. There's a reason why you have to wear a hard hat, you can't wear earrings, you can't wear certain things, because it is just so easy for some of these machines to hurt you. So I think it's really a great point to go that, well, if we start designing different, we can even save the people's lives that are making our designs. I can't tell you how bad I would actually feel if somebody perished because of the design that they were building for me. I don't know, it's just a terrible feeling. So if I think we can eliminate that, and if this simple process is the start of that, then by all means, let's teach it. But in our case, just to move on, we got our topography, but it doesn't have to stop there, and it's not really the only thing that has to be done by the laser cutter. To be fair, I could use the Make 2D and print this on just a regular 12 by 24 piece of paper, right? Guys, it's recording. Anyway, but potentially I could cut this by hand still, and to make it easier for myself, I could basically print a template, poke another piece of cardboard by hand, and still actually cut it out really well. So don't get me wrong, you don't necessarily have to use a laser cutter. And, well, that being said, how fast do you think that laser cutter goes when there's 40 students trying to cut in 3 days before a final model? Usually the last 20 students don't get to the laser cutter. So be prepared for something like that. So again, this methodology kind of sets to kind of combat that as well. However, as you guys saw, I made a copy of my last model, and this was kind of the model that we were using, that we kind of, well, more or less, we started cutting to in order to make that work, right? Now, we didn't get to every single piece, as you can see. Some things still need to go down maybe a little bit, and that's okay. Maybe we step over it. No, I'm just kidding. We could Boolean difference that, and I think we tried to actually last time. We can end up wire cutting it, or even moving face, right? So if you move that face, or push and pull, if you have Rhino 8, right, you can totally push and pull now. But you can also move things pretty decently as well. However, you do start to make some pretty interesting objects, and to be fair, you can make a lot of things because of the digital realm. There are a lot of things you cannot make because of the digital realm. So again, a lot of the reason I give you guys this project is that way we can start off in the same spot, and it's a little bit easier thinking orthogonally. Don't get me wrong, we can make some pretty intense objects. Even this cylinder is going to be kind of intense, but we can definitely do it. And one thing I would say is do it one piece at a time for this process. So for instance, we just got the topography laser cut, and we just made all the pieces for it. So we're kind of done with that, and I already do have a copy. So I'm just going to go ahead and remove it from the model, right? That way I can kind of eliminate one piece at a time. To be fair, I can either hide it or delete it. I already have a copy there, so I'm not too worried about it. But let's go one piece at a time, and let's say I got to get this piece, and that it's going to be solid. Now, there's a couple things I could do here. I could stack up a bunch of pieces. I could literally probably find a dowel this size and just cut it and put it in my project. So don't get me wrong, there's some easier things to do than what I'm about to do to this piece, right? First thing I would do is just go find a dowel this size and cut it, right? Not a big deal. Maybe with a bandsaw. It's not going to cut with a laser cutter in terms of that thickness, but it's pretty thick. So I'm going to take this piece and I'm going to unroll surface. Let's see what it produces. So unroll surface, enter. In my case, I'm going to try it without exploding first and press done. Now in my case, it'll look like nothing happened, but essentially it unrolls that surface. Nice. Another thing that's really nice about this, I didn't have to calculate jack, right? And normally I would have to find the circumference of that circle. I'd have to roll it out, make a rectangle by the height of that surface. Don't get me wrong, I learned all that in high school, and we used to do this in high school for AutoCAD training. We would basically build objects, print them out, and fold them together. It's literally all we did junior year. But I do think it's funny that it kind of comes back full circle, and it was probably one of the greatest lessons I've learned because it definitely taught me how to put things together. In my case, though, dang, that almost looks like it could be laser cut, you know what I mean? It's already flattened out for us, and to be fair, that's got the exact dimensions of this piece. I can't tell you how much easier that just got, right? But as you can see, we're not finished. We do need to make 2D to that piece. So I'd find it, make 2D, and get that piece, right? However, to be fair, take a look. It's gonna probably fall apart, right? Especially if I just leave it the way that it is. Now, what I would do, knowing what I know, is trim it out. So I would actually ungroup this, because by default, make 2D is grouped usually. And I'd want to trim some of these pieces off, right? So I'd take these two, trim, and that is actually what I would laser cut. To be fair, I could cut off this as well. Boop, boop, and leave that space. Arguably, even that's kind of too small, right? The next thing that I'd want to do is, yeah, well, I'm going to cut this out, but I'm still going to have to like sit there and bend it. So what can I do to make that easier to bend? I could score it. Now, to be fair, there is actually a mathematical way of doing this, but I'm not going to go over that and confuse you. In my case, it's actually simpler than it looks. You'll take a piece here, and we can array it, right? So in my case, I could either make several copies, or just array it, and give myself a certain number. So in my case, this is the Y direction, so I only need one in the X direction, enter. I'm going to go with like, I don't know, 24 of them in my Y direction, enter, and just one because I just want one layer of it in my Z direction. And it's going to ask for the point I want to start and the point that I want to finish. Now in my case, obviously that's not the point of finishing. I'm going to try and fake it till I make it and just get some lines in there, right? In my case, it's getting pretty close, right? Not too shabby, and that's probably fine. In my case, I'm going to hit enter and keep all those lines, and there was one that got outside of the box, and that's okay. But relatively speaking, I do need a few lines in there just so that I'm able to bend this thing. Again, don't get me wrong, you could 3D print or you could laser cut this out and you could score it by hand. There's definitely more ways than one to do this. But in my case, I would just switch it to a score. And I should probably switch my layers, by the way. Sorry, cut is supposed to be red. And score is supposed to be blue. However, at Texas Tech, it is the opposite. So there's a reason I'm a little confused. But let's take those pieces that I definitely need to score, and it's definitely not that outside piece. I definitely want that to cut. So again, I'll right click on cut and change object layer. This piece is ready to get laser cut. Well, almost. I still got to do this piece right here. And arguably, I do maybe want to make it easier for myself. So another thing that I could do is what's known as a tabature, right? I need to create some tabs. I mean, haven't you guys ever pulled apart the cereal box and noticed that there was kind of glued tabs holding each other? Well, we can do the same thing. To be fair, they're actually really easy. We'll double click, and you can kind of imagine it, right? This is going to roll up, and it's going to create that cylinder. So what do we need on one of these sides? Something to kind of hold it, right? And something that we can actually glue upon. Don't get me wrong, I could add another piece, right, and really stick it in there, or I could make it really easy for myself and make a tab. So in my case, I'm just going to use, yes, I normally don't use near, but in this case, actually near is great. All right, I'll use near, and I'll make a tab. Now, to be honest, it doesn't require like a lot of knowledge there, but in my case, I do need this to get cut out, but uh-oh, what's going to happen if I leave this blue? It's going to accidentally cut off my tab, man, and actually make it useless. So in my case, there's a couple ways we can do this. As you guys know, I can just trim it out, put a new line there, and make sure that it's red, or in this case, blue. Here, let me fix that real quick. It's kind of annoying. This should be red, because I don't want to confuse you guys for the video. So let's change that back to cut. And score. Let's make sure that these are all scored. Sweet, that is the correct colors. Red for being cut and blue for being scored. But in our case, as you can see, the material continues. It's gonna be hanging on by a thread, but it'll work. And to be fair, you only need one tab, right? That tab is just gonna come up and it's gonna do that, right? You just glue right on that tab, and what's nice is right at that line is where that cylindrical piece will finish. To be honest, once we do that, what are we gonna have? We're gonna have these like little Mickey Mouse flaps going on, right? Both one for the bottom and one for the top. If I know that my piece is going into the ground, do I really need both? No, I don't. So is that really gonna affect my day? Probably not, but I could also take this, move it, and put it back. So I probably don't even need the top. So I'll keep, or sorry, don't even need the bottom, so I'll keep just the top piece. And I'll, again, just make a few little tabs for myself. Doesn't have to be really anything fancy. Again, these are actually what get hidden. And you'll notice that I leave kind of like a diagonal. Again, that's actually just for the strength of the piece, right? To be fair, you probably can't do that so much on a curvilinear piece. To be fair, you probably should do something more like this, where the diagonal's going the other way. Does anybody know why? It's going to fold in, and it's definitely on a curvature. You're exactly right, Cole, and thank you. So I'd probably want to do it the other way. Trim, and make sure that I trim this piece out too, or make it into a score. Now this is where this will become more in handy. I don't just want to trim that and put a line there, because it does need to kind of stay at that curvilinear rate. In my case, I'll select the line and type in break, and basically select one point to another, and it'll break that line, right? Another thing that we could do is, well, we could break it in a certain way. So break, I could break it from here to there, and I could break this one from there to there, and I can keep that curve. Another thing I could do is extend and make that piece hit, and make that piece hit as well. That way it's 3 separate lines. But now I can trim those off, and and we're good to go. Well, that one needs to become blue, and those need to become red, right? So I'll change these to cut, and change this one to score. Because anytime that you're folding, you definitely want it to be a score, not necessarily a cut. Otherwise, you'll get a bunch of tiny pieces that you didn't need in the first place. After I do that, I mean, I don't have to like reinvent the wheel. I could just use that and mirror it. After all, it is a circle, so if I find the center point of that circle, I should be good no matter what. And get that again, center point, and I can create myself actually quite a few tabs. Just in time for the holiday rush, right? It's looking kind of like a spider, a very cute spider. But I'd want to do the same thing, break this up a little bit. So break from this point to this point, awesome. From this point to this point. This is why near is so dangerous. You can just absolutely click anything accidentally on near. You'll see what I mean. Go ahead, try and use near. But now, and see, this is what I meant by like, yeah, I could spend the time just cutting these out by hand. That's fair, that's true. And arguably for some of us, you might feel like, wait, I'm way faster at just cutting this by hand. And that may be true for right now, especially kind of just behind a learning curve, that you're feeling like, man, this is way too much work to get one little piece. Eventually it does become second nature like I'm doing today, right? I'm like talking at the same time while creating these pieces, and it does become eventually kind of second nature. But I would definitely practice, guys. Try to get a few pieces at least. However, not every single piece will need to be necessarily laser cut. Now, yeah, we could get the volumes, and potentially I can make that out of museum board or chipboard or whatever I feel like. But for the sake of this model, please, for the love that is all holy, don't try to make the rails. Rails are not required. They're like this big, and you're just going to get frustrated and mad at yourself. And I've never required them. In fact, I had a student one time, the first time, they were like, can I still make the rails? And I'm like, go for it. And they hated themselves. And they thought that I was still like challenging them. He's like, you said I should do it. And I was like, no, I didn't. You were just very focused on doing those rails. So again, rails not required. Now they are for the drawings, but so keep them, right? But for the sake of the digital model, or sorry, the physical model, no way. But we will need the stairs. So what do we do with these stairs? Can we unroll them? Let's find out on today's episode of Computer Graphics. So unroll surface. Let's see what it produces. Enter. Produces something, but let's take a look, a closer look. Let me ask you, will that work on a laser cutter? Why not? They're all intersecting and overlapping. Thank you, guys. And in this case, if you ever get all these like weird ISO curves, that's what those curves are called. They're basically all the midpoints of the object. You can also select the object itself and unchecked show ISO curve. I think it's easier to look at. Some people like the ISO curve there, and again, sometimes I do too. But clearly, as you can see, what's nice is not only is it made 2D for us kind of automatically by unrolling it, but it's also showing us all the pieces that we need. So for instance, if I ungroup this, which I think it's grouped by default, yeah, grouped. Oh, maybe I actually do have to explode it. So as you can see, well, explode is kind of nice because it does give me every single piece. And well, notice how some pieces really are still aligned, right? So for instance, these pieces, they're still aligned. See what I did there? Even though that's one whole piece, I just exploded it and took it apart so that it doesn't overlap. Couldn't I just cut those two pieces by laser cutter and tab them together? I could make a tab, couldn't I? And just put a tab right there and put them together, right? Now I'm still gonna kind of have to more or less do the exact same thing I did here, right? I'd have to turn these, and yeah, there's still some overlap. To be fair, we're not gonna try to laser cut the stairs. Please don't be a hero. Unless you got some floating stairs, right? You got little individual pieces on a rafter. Sweet, cut the rafter, cut little pieces and glue them on. Or you can find dowels or basswood that exact size you need and just cut them at the lengths that you need. In fact, I could even print this so that I can get the exact length and number that I need, right? So again, use this as almost like a template making machine. And essentially, well, you guys know what you're capable of, right? What you can do by hand, and what, of course, you can save time by doing laser cutter or saving your blades or hand, right? For obviously the stuff that you need to be accurate, such as the stairs, right? So that's looking pretty good, but let's switch it to cut and make sure everything's going well. So in my case, go back to layers, switch it to cut, change object layer, and switch that to red. However, it looks like I need to explode it again. And all these are going to be folded, so I'm going to turn those into, oh, I got to ungroup them, I guess, too. And I got to spell ungroup correctly. There we go. But we should have some individual surfaces. Ah, so what do I have to do to that? Make 2D, right? So keep in mind, it is actually still a three-dimensional poly surface. You can't just 3D print or laser cut poly surfaces. You can only cut lines. Right, so we do have to still make 2D. My bad, misspoke earlier. There's the one that we can actually change. This one, get out of here. We've already unrolled you. You're fair. But as you can see, I got to do this piece by piece, and I really do have to methodically think about each piece and how it's either going to be cut by hand or cut by laser cutter. The last piece I want to go over is, again, simply making a template is not uncommon, and it's not like a faux pas, oh, you couldn't use a laser cutter, it's okay. However, you know, for like some pieces, you'll realize like, dude, I don't really need a laser cutter here. In my case, like for instance, my grids. Well, I know that I have a certain lengths of these going on, and I know that I have a certain amount of them. So for instance, I'll turn off everything except my grids. Boop. Oh man, I accidentally got rid of my grids. See, this is exactly why you should label things correctly. Unlike Professor Verrett today. So let's find grids. I think I got them somewhere. Nope. There we go. Close enough. However, I should have put those in the right area. Again, I know these are all for the sake of tutorial, but again, this kind of helps you out when you have the right thing. What's nice though is I can create a template for, like, say, buying basswood pieces, right? So I could take a view of this to scale and actually use it as kind of a governing template also to build this, right? So make 2D. I could use it to produce an elevation. Use it for a lot of things, but I could definitely use it for fabrication. So it's going to create that piece for us. And it's not going to show it because I don't have make 2D on, so make sure your make 2D's back on. There we go. Should be somewhere. There it is. As you can see, I accidentally have some of my make 2D lines in there. Let's try that again. And I'm going to hide this real quick. That way it's a little easier to see. Hide, and get out of here. But yeah, let's say I was using that as a template for my basswood pieces. Make 2D. Sweet. Of course, forgot to turn it on again. Damn it. There we go. But now I can put this to a piece of paper, and I could actually figure out the size and scale of the piece of paper. We find out that this model is at 1/8 scale, and technically will fit on just like a regular letter size piece of paper. However, at 1/8 scale, what do we have? 8 times 11, so 88 feet. And what's 8.5 times 8? I gotta use a calculator for that one. 8.5 times 8. 68 feet. Didn't think that was going to be a straight number, but all right. So there's that ratio of what and how big that would be. So again, now I can just send this to the printer real quick. Dude, that saves me so much time than trying to, I mean, can you imagine if you just sat here, and trust me, this is exactly what I did, which is why I'm trying to persuade you not to. I used to sit here and get my dimension line and sit here and go, okay, that's 30 feet. Okay, I need so many of those. I'm gonna measure them out. I'm gonna make sure I can get my scale. I'm gonna do all that when I could just print it out already to the scale and the size I need. So potentially I line up now my long 24-inch piece of dowel wood, line them up, cut, line them up, cut. line them up, cut. Because now I have this paper template that I can go off of. So again, just wanted to share that there's a multitude of ways that obviously we can tackle this. Not everything has to be the same way. Not everything has to be laser cut. Not everything has to be by hand. So again, just wanted to express that obviously we'll have to do this piece by piece. So yeah, you'll have to make the stairs. You'll have to make all these random volumes. To be fair, this one, if you just find the thickness of the surface, you can just probably unroll that. See what I'm saying? Anyway, I'll end it here for today just because it will be quite the lengthy video. Obviously, just to recap, we went over how to set up to the laser cutter, make our pieces, and dive right into taking this apart, and essentially go to the laser cutter, cut it out, and put it back together, right? So, of course, what that all means. Now, next, I'm going to go find some of those models I was talking about and bring them in so that you can take a look. I think I've shown them before, but maybe not at the detail that now you're aware of. So, any questions so far, guys? Fair enough. We'll end it for today.